Hello everyone, Namaste, and this is Srikanth Rangdar, and in today's video we are going to solve some previous year question paper problems because Monday there is a exam for OU students, and I thought making this video at this particular time will be helpful not just for the students who have backlogs, the examination on Monday, and also students who are studying kinematics of machines this current semester. So let's go ahead and see what are these questions. So this particular question paper appeared in December 2020 for 4th sem students, and only 2 hours were allotted for this particular exam. So we have been told to solve any 5 questions from this party. I think this is the corona pandemic's time examination, and hence the difference between marks and number of the amount of time that is provided. Let's go ahead and solve this up. So first okay, so first question is classification of kinematic links. So you can see classification can be done on various different bases. So based on rigidity, the links can be classified as rigid, resistant, and fluid. Resistant links being those which are rigid only in one particular direction, like for example the chain or a belt. They work only in tension, whereas when it comes to compression they are unable to maintain the rigidity, and hence they do not they are not able to work as kinematic links in transferring motion. Then based on the number of joints, links can be classified as binary, ternary, and quaternary. Let's see what's the next question. So next question has to do with instantaneous centers. So the types of instantaneous centers is what he's asking. So first is permanent and fixed, and then permanent but not fixed, and moving, you can say, and non-permanent. These are the 3 types of instantaneous centers. So since this is just for 2 marks, we can just mention them, and we did not actually draw a diagram. If required to draw the diagram and show it, we could just do that over here. Let me just show you how it happens. So let me just take an example of a 4-bar linkage over here like this, and let's say the bottom link is fixed. So in this case we can have the link numbers 1, 2, 3, and 4. So for this, the instantaneous center 1, 2, this is instantaneous center 2, 3, this is instantaneous center 3, 4, and this is instantaneous center 1, 4. So when it comes to the instantaneous centers, instantaneous center 1, 2 and instantaneous center 1, 4, these are permanent and fixed. Permanent, and they're also fixed. Okay, so next we have 2, 3 and instantaneous center 3, 4. These are permanent because they cannot break, but they are moving. Okay, and then we have the other type, those which are neither permanent nor fixed. So for them I had to place that over here. Let me take this and over here. So I had to extend this part over here and this part over here. Okay, so what we end up getting over here is the instantaneous center for 1, 3. So we know the kinetics theorem. It states that the 3 kinematics centers of a given link are going to be located in the straight line. 3 in centers, say in the line theorem. So 4 and 4 is going to cancel. 4 and 4 is going to cancel. We get 1, 3 over here. The same way over left side as well. You can see 2 is common, so 2 will cancel. We'll again get 1, 3 instantaneous center 1, 3. The same thing we need to do on the left side as well. So let's go ahead and do that. We need a straight line. We need to extend this over here. This, when extended somewhere, it's going to meet over there. I guess we are limited in this let's first remove this. Or there, and instead of that, let's provide it the darker link over here. It's gonna work out. So this is instantaneous center 2 and 3. So once again here 3 and 3 will cancel, we are left with 2 4. So this is instantaneous center for 2 4. The same thing happens over here. 1 is common, so 1 if cancelled, we are left with 2 4. So these two instantaneous centers 2 4 and the instantaneous center 1 3, they are non-permanent and moving, neither permanent nor fixed. You can say that as well. So these are the three types of instantaneous centers. So let me just take a snip of this, place it over there for reference. Okay, so this is our solution. Let me place it over here. Use this line there. Okay, then state the laws of static and dynamic friction. The static friction laws go like this. The friction is increases with the applied force till maximum value called limiting friction. And second point, you can say that the limiting friction is proportional to the normal reaction between the surfaces in contact. Alright, and dynamic friction. Dynamic friction, same thing, this one will again come up over here. Limiting friction is not limiting friction. The dynamic friction is proportional to the normal reaction between the surfaces in contact. That is the first law, you could say. And second law, you could say the dynamic friction is lesser than the static, or say not static, it's the limiting friction. Okay, and you can also say the coefficient of kinetic or dynamic friction. Coefficient of static friction. So these are some of the laws we can just write in these 2 points. We can also mention up here. Anyway, so let's go for the next question. Define the following terms as applied to KOM with an 8 sketch. The base circle and stroke of the follower. Okay, so let's go ahead, go back here. Let us say this is our KOM. Okay, then this, let us say, it's our follower, straight line follower. Just say this is the point about which it is turning. Then the circle of the minimum circle which touches this KOM profile is called as the base circle. So let me just take this and over here. Fine. So this is the minimum circle with minimum radius possible. Fine. So this is the point this point here is the lowest position of the follower, so this circle here is the base circle. This circle is the base circle. This is the cam profiles. This is the center of rotation. This one is the follower. And what else is he asking? Base circle and stroke of the follower. Stroke of the follower will be dependent on the maximum distance. If we take this is the line about which the follower is, this is the axis about which the follower is reciprocating. So axis of follower. So stroke is the maximum length by which the follower moves. Okay, so we can just type this over here. Stroke of the follower, the maximum displacement undergone by the follower. And base circle is the circle minimum radius that is tangential to the cam profile. These are the two definitions. You can also just throw in this diagram here for clarity. That should do, I guess. Right, state and prove the law of gearing. The law of gearing is slightly difficult when that is the solution we're looking for. This is what it expects. Then lower pair and phase and acceleration diagram. So link number 1, link number 2, link number 3, and link number 4. So this is the position diagram, you can say. And if this is the omega value, and let's say omega value is constant, then we will get the acceleration diagrams. Fine. So the first acceleration diagram we will get is the centripetal component of the tangential diagram. The centripetal component of A with respect to O, that's written as O dash A dash. Okay, so this will be towards this in this particular direction. So let's start it. You can see here an acceleration diagram has been given. Let's just keep the same thing over here. Right. So there is no need for showing these lengths because he has not asked any particular values for it. So you can just take this. The upper one is position diagram, the lower one is acceleration diagram. Okay, this is what we want. Then I explain briefly about the design of a disc clutch with its sketch. This clutch, okay, how is it designed? disc clutch. The plates like this. Brake lining will be there around here. So when these brakes are pressed, the contact breaks, and when it is released, the contact is again set up. I'm pretty sure this. You just show it as this. So, okay, so that's the gear train. Various types of gear trains. Simple gear trains. We have compound gear trains, reverted gear trains, and then we have epicyclic gear trains. Cams and followers. There are lots of different types of cams and followers. Let's see. It's asking explain, but it is not enough time to explain each and every one of them. It is just consists of 2 marks. So just mentioning the name should suffice. That's it for this. So here we have the next question. This is a long answer question with 2 bits. First bit is asking us to explain about Robert's mechanism with a neat sketch. So the Robert's mechanism, it's a very simple mechanism. There are 2 points over here, and straight line motion is executed by the mechanism between these 2 points. So we will need this. Okay, so half of this length needs to be put into here somewhere. Okay, this needs to be connected by way of a line to these points. Okay, so this inner one, this completely is a single linkage. Fine, this is a single linkage. So these 2 points are fixed. Okay, so this can be called as link number 1, that is fixed. This is link number 2, and we have this link number 3 and link number 4. So this is the Roberts mechanism. Okay, so the point that we can call it as P over here, this point P travels in a straight line. Right, so within these 2 limits it travels in a straight line, so it can be called as an approximate straight line mechanism. Okay, Robert's mechanism is an approximate straight line mechanism. Let's put it down here. There. Let's put it here. So that is the Robert's mechanism. This. Okay, explain about it. What is there to be explained? Okay. Okay. Or some where the coupler is triangular shape as shown in the diagram. The corner P of the coupler travels approximately a straight line. Okay, so let's also talk about the lengths. Okay, for lengths we will need to mention the points. So let's call this as O. This is, instead of this, let's call it as A, B, C, and D. This part is of course P. Let's take this. This is the mechanism. Lengths AB is equal to BC, it's equal to C, sorry, not is equal to BC, it's equal to BP, it's equal to PC, it's equal to CD, and BC is equal to AD divided by 2. Lengths their lengths are related as this. The corner P of the coupler travels in approximately straight line between the points A and B, as shown by line. Right. That's for this. That's for the A bit. Now about the B bit, he's asking us hooks joint. The hooks joint. So let us say this is one end, and let's take a different color for the second, this cross thing, and let's say a third color for the next link. Okay, like this. So let's say this here is the angle. So this angle is represented, is written as alpha. This angle is written as alpha. The angle of rotation here is theta. So we have been asked to find the angle theta. We have asked to find the angle theta for two conditions. So the first condition is the velocity ratio is maximum. Velocity ratio is omega 2 by omega 1. So when this is maximum, this is for A bit, and B bit when it is equal to unity, that is 1. Okay, so now we know the formula for omega 2 by omega 1. That is given by the relation cos of alpha divided by 1 minus sine square alpha and cos square theta. So this relation we have to use, and we have to apply these two conditions into this relation in order to find the solution. So when omega 2 by omega 1 is maximum, that's when d by d theta of this particular equation has to be equated to 0. Maxima condition we need to apply. Maxima condition is d by d theta of this whole equation. So equation should be equated to 0. This will give us the maxima condition. So cos alpha is constant, and this thing we have to take 1 divided by 1 minus sine square alpha cos square theta square, because 1 by x is 1 by x square. Multiply this with integration, differentiation of this, that gives us 2 cos theta into sine theta. That is negative. So negative somewhere, it's just going to cancel, and this total has to be equated to 0, which means this and this entire thing is going to cancel, and we get sine of 2 theta equal to 0. So that means 2 theta is going to be 90 degrees, or theta equal to 45 degrees. So these are the angles. These are the angles where where the velocity ratio is going to be maximum at 45 degrees. Then when the velocity ratio is going to be equal means when they're equal, that means omega 2 by omega 1 is equal to 1. So that will happen when cos alpha will be equal to 1 minus sine square alpha cos square theta, and we've been given the value of alpha, that is 18. So alpha is equal to 18 degrees. If we substitute, we will get the value of theta. So cos square theta is going to be 1 minus cos alpha divided by sine square alpha minus cos alpha So 18 divided by sine 18 square, 0.51. So now that we know cos square theta is this much, we'll have to find square root of answer, and we have to take cos inverse of that. Inverse of answer. You're getting 44.28. So theta is 44.28 degrees. So this could be plus or minus, because it is cos inverse. This can be plus or minus. So this is the solution. But that's very close to what we got here. What can that be? ये 45 डिग्रीज होना चाहिए ना यार. Anyway, will be 0 or 180 degrees. These are the two values of angles for which 2 theta remains 0. Then following this, we can calculate theta as either 0 or 180/2, that is 90 degrees. So these are the two values. These are the two values wherein you could say that the ratio remains maximum. And for the ratio to be unity, that means input velocity equal to output velocity, the same structure. So that there will be actually 4 angles here, plus or minus this, and 180 plus, that will give us the same result. Plus this and 180 minus this, also gives us the same result. This is what the diagrams will look. This is the uniform velocity circle, and this is the output, that is not uniform. This is the input, which is uniform, and it is the output, which is not uniform. And these are the 4 points where the velocities, the input velocity will be equal to the output velocity, and at 0 degree you can see the maximum equation, and as well as at 90 degrees there is the maximum equation. The same thing repeats here on this side, that is 90, and this side that is 20. Okay, so there are 4 such places where the input velocity is equal to output velocity, and also 4 such places where the ratio between input and output velocities is maximum. So that's what I have placed over here. I'll be sharing this in the description below. If you want, you can take this. And okay, we have this next question on a simple band break. Right. The diagram is also given in the question, and we have been told that the mass of this drum, the mass of the drum is 400 kgs, and the radius of gyration, that is k, that value is 450 mm, and then radius of gyration is 450, and it is running at 300 rpm. So n value for the drum is 300 rpm. With the coefficient of friction, that coefficient of friction is given, that is 0.2, and the brake drum diameter of the brake drum, that is given over here, that is 240 mm. We have to find the torque required to a hand load of 100 newtons, due to a hand load of 100 newtons. So when 100 newtons of force is applied, what is the brake torque? So brake torque is what we need to find first. And yeah, so first bit, let's go ahead and do this first. So in order to solve this, first we'll have to take the free body diagram of this particular object. So let's take a free body diagram of this. Okay, so we'll have to reduce this a little. Okay, so this is the free body diagram. The free body diagram of lever, this is coming out like this. So T1 is the tension here, T2 is the tension here, and 100 newtons, this is the value of force that is acting over here. And okay, so even though it's not mentioned, the point O is where the pivot point is fixed. And so we'll have to take the sum of moments about O to be equal to 0, because that is the point about which it is in equilibrium. So now let's take all the forces one by one. So T2 times 120, this is going in anti-clockwise direction, so plus, plus, and then 100 times 300, this is going to move in clockwise direction, so it's going to be minus. T1 will not cause any moment, so it's going to be ignored. So this total has to be 0, and with this we will be able to find the value of T2. So T2 will be 100 into 300 divided by 120. Let's go ahead and do the calculation for this. So 100 into 300 divided by 120, that's 250. So 250 newtons is the tension at T2. 250 newtons is the tension at T2. Now we need to find the tension T1. So in order to find tension T1, we know the formula for ratios. T1 by T2 is equal to e power mu theta. And here you can see that theta is the angle of contact. The angle of contact theta is 180, which is the straight line, plus this angle, that being 30. So 180 plus 30, that gives us 210 degrees. So this degree we need to convert it into radians. Fine. So pi by 180 degrees we'll have to multiply. So degree are going to come up here in opposite directions, and substituting this value, we will get the value of the angle in radians. So 210 into pi divided by 180, so 3.67. Fine. So this is the value in radians, and the radians value need to be substituted over here, not the degree value. So now that T2 is already known to us, so T1 will be equal to T2 times e power mu theta. T2 value being 250, e value is there in the calculator, and mu value is given as 0.2. Theta angle in radians, we calculated it as 3.67. So that will give us the value of T1. So let's see what that is. So 250 times e to the power 0.2 into 3.67. This has to come in a numerator, so into 3.67. So that gives us 520.85. So this is also in newtons. So now that we know both T1 and T2 values, you can see T1 and T2 values are acting on the drum, and braking torque will be T1 minus T2, that being the force, multiplied with the radius. Okay, and yeah, so we know both the values. So 520.85 is the tension T1, tight side tension. 250 is the slack side tension, and we know the diameter is given as 240, so radius will be half of that. And because this is in mm, we have to also divide this by 1000 to convert this into Newton meters. So let's quickly do the calculation. So 520.85 minus 250, this needs to be multiplied with 240 divided by 2000, so 32.5 Newton meters. This is the value of braking torque. So we were able to find the first bit is solved. Now the second bit he's asking is the number of turns of the wheel before it comes to rest. So theta displacement we need to find, provided the angular acceleration is constant, or we could just use the relation between work done and kinetic energy. The work energy relation is what we call it. So work is equal to the kinetic energy. Work is theta times the torque that is applied. That's equal to half of the, because this is a drum, so this will be I omega square. Now in order to find I, we can take the relation mk square. Okay, and both m and k are known. Let's substitute. That is 400 times k value, because this is given in mm, we need to convert this into meters. So 0.45 square. So that gives us 0.45 square, 81. So 81 kg meter square. This is the value of I, and this value I we have to substitute over here. Coming to omega, omega can be found as 2 pi n by 60. Okay, so n value is given over here. Let's substitute that here and find the value. So n value is 300. So 2 into pi into 300 by 60. That gives us 31.42 radians per second. So this value again we need to substitute over here. And then torque value we found how much? Yeah, 32.5. So theta into 32.5 will be equal to half 81 times 31.42. So that gives us the value of theta. So for theta, you have to take 81 into 31.42 divided by 2 and 32.5. So that's giving us 39.15. Now the value that we got here, it's not in degrees, it is in radians. It's in radians. So if you want to find the number of turns, if you want to find, so this theta needs to be multiplied by 2 pi, because 2 pi radians make one complete rotation. So let's do that. So we'll have to take answer divided by 2 pi. So that's giving us 6.23. So these many rotations. Okay, so that means 6 complete rotations and about almost a quarter of another rotation. So 6 and 1/4 rotations it's going to complete till it comes to rest. So that means we have solved the second bit as well. Then he's also asking the time required to bring it to rest from the moment of application of a brake. So here of course we can assume that because the friction is remaining constant, the torque is remaining constant, so we can assume that alpha also remains as constant. And for constant value of alpha, there are 3 equations of motion we can apply. That is omega 2 equals omega 1 plus alpha t, then theta equals omega 1 t plus half of alpha t square, and then 2 times alpha theta equals omega 2 square minus omega 1 square. So now this relation doesn't have time in it at all, and this relation is a little more complex. We don't know, we know the final velocity, this is known. We know the initial velocity, which is a constant. The final velocity is 0, and so of course we can use this relation, first relation itself. So omega 2 we know it is 0 because it is coming to rest finally. Omega 1 is the value that we just now calculated over here, so that is 31.42. and alpha value, even though it is constant, but we still don't know the value of alpha. We don't know the value of alpha, but we have found the value of theta. So this has become a bit more complex. Alpha value is not known, alpha and t both are unknowns. So first I think we'll have to find the value of alpha, then we have to substitute it here in order to get the time. Okay, so we have to use the third relation. I had assumed that we won't be needing the third relation, but Turns out this is the first relation we have to use. So 2 times alpha into theta, that is 39.15. When you are substituting here, we have to substitute the radians value. Omega 2, of course, it is 0, and minus omega 1, omega 1, the initial angular, that is 31.42 square of this. Now alpha is going to be negative because it is deceleration. Let's find that value. It's 31.42 square divided by 239.15. So 12.61 radians per second square. This is the value of alpha. Now we can substitute that, and we can find this one. So omega 1, so this is of course negative, plus alpha into t. So this is 0, omega 1 we know 31.42, and this becomes minus 12.61 times t. The t value will come out to be 31.42 divided by 12.61, so 2.49 seconds. So this much time is required for it to come to stop. So I hope you have understood this question. If you want more questions, please subscribe to the channel and stay connected. As soon as I get more time, I'll be solving more problems from the previous papers. Thank you for now. Goodbye.